Hello, my name is Adrian Chavez.
My name is Raymond.
I'm Hernandez.
And we're going to speak to you today about the electric car. What is an electric vehicle? An electric vehicle is any vehicle that uses power stored in batteries, which in turn move electric motors. Electric vehicles are extremely efficient. They use no fossil fuels whatsoever, and this leads to virtually no emissions unless you have battery waste and things like that. Electric vehicles have extremely high performance compared to internal combustion engines. Torque curves are virtually non-existent. Torque is equal throughout the entire operation of the vehicle. Some popular models of electric vehicles are the Tesla Roadster, the Chevrolet Bolt, and the BMW i8. A general layout of an electric vehicle: you have the batteries, which are usually on the bottom of the vehicle for weight savings. You have the electric motor, which is located centrally, followed by a gearbox, which in turn gives the power to the wheels. In some other layouts, you'll have electric motors that are smaller, which are called pancake motors, which are in each wheel, which give a little bit more better performance for cornering, things of that nature. And the battery types you'll have are lithium-ion and lead-acid batteries. Hybrid vehicles. Are hybrid vehicles technically electronic vehicles? In this case, yes, because they do utilize the same electric motor and battery system. Hybrid vehicles use internal combustion engines, followed by a small electric motor, which have generators which charge the batteries that are on board the vehicle. They are much less efficient compared to a fully electronic vehicle because they do utilize the internal combustion engine, and they will be able to charge the onboard batteries, which in turn counteracts the efficiency. The electric vehicles are gaining popularity in this industry. Tesla is the industry leader, and through the industry we see motorsports getting more active, which is, you have electric vehicle racing in all forms, as well as Formula E.
Okay, so a little bit of history about electric vehicles. Most people don't know that they were actually the primary way to get around when the automobile was being invented. They were much more reliable and practical than mechanical vehicles at the time, because mechanical engines had to be started with hand, which was very dangerous and very hard to do for most people. They also had steam-powered cars, but they were really inefficient, especially on cold days, to get going. So they were popular until about 1900, when the Model T came out, and it was actually the invention of the electric starting motor that killed the electric vehicle. This led to the ease of being able to operate mechanical cars, and also led to the development of highways, which there in part limited the range of electric vehicles. So they fell out of favor. So electric vehicles pretty much remained in the shadows until about the 1950s. They were starting to get looked at again, but they really actually came into light again when the fossil fuel crisis happened in the 1970s with the oil embargo. The first hybrid vehicle actually was developed by Victor Woke, and it occurred in 1972. It effectively doubled the mileage of the standard motor gasoline car, and it came with a 9% efficiency improvement, which was huge. However, the oil embargo ended, and electric cars then faded out of necessity again until GM developed the EV1 in 1988. This vehicle was widely loved and widely desired by users. They were in service until about 2003, when production stopped of all parts and GM recalled them back. So that leads us to the new models of electric cars. Tesla is definitely the biggest manufacturer right now when people think about electric vehicles. They came out in 2008 with the Roadster, and ceased making that and began making their Model S and Model X variants in around 2012. Other manufacturers have also stepped up and seen the need for electric vehicles. Mitsubishi, Chevrolet, Ford, Honda, and Toyota are just a few of the manufacturers on this list. We all have electric vehicle variants. So leading into that is the design of current vehicles. As Adrian had mentioned, the electric vehicle pretty much consists of three primary components: a battery, a motor, and a controller. So dealing with the batteries. As Adrian mentioned, the two common ones are lead acid and lithium iron. There is also nickel metal hydride and zebra, however those two are not generally used on electric vehicles. Batteries are placed in the chassis and they're down to the floor. This puts the weight very low and makes the center of gravity very low on the vehicles. Okay, so leading into this is the motors. There's two types of motors, AC and DC. They both have their ups and downs. AC is far cheaper and far more common to use, as well as they allow for regenerative braking and a more efficient packaging. DC are larger, however you don't have to have an electric converter type to convert the DC to AC electricity, and you can temporarily boost the output of a DC motor 5 times what it's rated for. This, however, could potentially burn the engine. The last thing and component of the electric vehicle system is the potentiometer or the controller. Early vehicles use a potentiometer, which is basically like the dimmer switch in your house. However, this isn't very advanced. Modern day vehicles use what is known as a microcontroller. The microcontroller allows for easy and reliable transition of power to the engines, and it prevents the motors from being damaged in an over voltage case.
So the advancements that we're looking towards in the future now are based a lot on carbon nanotubes. This material is showing great promise in 3 separate areas. One, it's very strong. It's 100 times stronger than steel, and it's 1/6 the weight of it. 2, it can carry large currents and generate very little heat. And 3, there's actually some studies being done on using the same material or a variant of it to actually produce photovoltaic type cells in order to generate electricity from solar. Battery advancements. One of the new advancements that we have in the works right now is start a company in which they've created a process of changing the anodes, replacing it with a silicon composite instead of a graphite anode. With this change, they are seeing an improvement of 40%, which is unheard of in battery advancements. The next step we're hoping that comes out is standardization. Once battery sizes are standardized, as far as their dimensions and their capacities, their plugs and all that, the cost of the actual battery is going to drop immensely. We're also in the future going to have battery swapping stations. These stations are going to have your standardized batteries, much like a gasoline station now, but instead of having 168,000 gallons of fuel, you're going to have warehouses of batteries, and cars are going to drive up. It's going to be an automated process. Batteries are going to get swapped out. In a minute or 2, you're gone. Motorsports, as Adrian had mentioned earlier, is one of the ways that we benefit from technology and advancements. Motorsports is a huge driver in advancements in the internal combustion engine, and it has been as well in the electric vehicle. On the left here you see a modern Formula 1 engine, which actually is a hybrid engine nowadays. It's a very small, high-revving V6, 1.6 liter turbocharged, but it also has an electric motor. It's about 600 horsepower on the engine and 160 on its electric motor. On the right there you see a modern Formula E vehicle with the motor and the battery pack. The motor on this vehicle is actually from another production car, which is a McLaren. In the last 145 years, it seems like we've actually come quite a ways. You know, back from basically having a horseless carriage with a lead-acid battery and a small electric motor to this very futuristic, incredibly fast and efficient Formula E car. And that's the end of our slides, of our presentation.